Cool. I'm from Airbus. We make things that fly. I'm a senior software engineer, probably more senior than software. I'm a dabbler in iOS because most of my day job is about doing avionics systems, so I can't do a lot of iOS stuff, sadly. But I thought I'd talk about how you might go about unit testing storyboards, something that I started looking at a little while ago. Well, segues, that's not the sort of segue I'm talking about. Well, I found that picture and I thought it was rather amusing. So, what is a segue? Well, we have what you call a presenting view controller, a presented view controller, and this thing called a segue that joins them up. And it looks a little bit like that in Xcode. So here we tap on a button, hopefully, and it moves to the next view controller. So that's basically what a segue is, if you didn't know. Why would you want to unit test a segue? Well, it's faster than UI testing and manual testing, and you may be doing test-driven development, perhaps. And it's always not always just about testing requirements. You may want to do non-regression testing, so if someone accidentally deletes a segue, it'd be nice to know about that rather rapidly, if that's at all possible. To get a bit of an understanding about what goes on, probably need to look at what actually happens during a segue. This is from Apple's View Controller Programming Guide. The segue here is initiated by tapping on a row in a table view. A couple of things to note about this. First of all, most of the work's done by the presenting view controller. That's the one on the left. It's possible to prevent the segue from occurring by implementing this method called should-perform-segue with an identifier. The presenting creates the segue, but the segue actually creates the presented view controller and loads it out of the storyboard. We can pass data between view controllers, so if you've got model data to pass, if you implement prepare for segue, you can pass that data across from one view controller to the other. And the presenting view controller is actually in charge of displaying the presented view controller, not the segue itself. Interesting. Bear that one in mind in a minute. So what do we want to actually test when we do unit testing on a segue? It depends a little bit on the type of segue. Maybe it's a push segue, a modal segue, or a popover, or some other type of segue, maybe. But generally, you want to know that you've got something to initiate the segue with, so you've got a button that exists. You want to know that the segue itself exists. Also, we need to give it an identifier. So if you're going to use prepare for segue, you should have an identifier in there. And we want to know that the presented view controller is actually presented, and if you're going to pass model data, that model data is passed as you expect it to. One thing not to test is Apple's code. Hopefully they've tested it themselves. At least we're going to assume that anyway. But don't test things that you don't have control over. Because if it fails, what are you going to do? There's a couple of challenges with this. How do we access the presented view controller from the presenting view controller? We want to access the model data. If we can access a presented view controller, we should be able to get to its model data if you've designed it that way. We want to test that the segue exists, but how do we get access to the segue from a table view or a row in a table view? So accessing the presented view controller. The presented view controller from the presenting view controller. Presenting. I'm going to use this thing called what I've called a swizzling spy. What do I mean by that? Well, there's a couple of concepts involved in here. The first one's called method swizzling. That's where you change the implementation of a selector or a method at runtime. And the other is a test double called a spy. If you've ever read Jared Mazur's X-unit test patterns, There's lots of different types of test doubles rather. There's spies, mock stubs, fakes. This one, we call it a spy. He defines it as a test spy is designed to act as an observation point by recording method calls made to it by the system under test, whatever that means. So basically what we want to do is replace, or a spy or a test double replaces an object that the system under test, in this case our presenting view controller, depends on, and that dependent object, then we can get inside what's going on in the dependent object. This is a little bit different because we're actually replacing functionality of the system under test itself, which is the presenting view controller. So as I said before, it's responsible for displaying the presented view controller with a method called present. Who'd have thought? It uses the function present, and something to note about this function, it has a parameter called ViewController to present. So that's how we can get access to it. So what we want to do is access this method, and we use Swizzling to replace that implementation of present with our own implementation. We capture the parameters that are passed to that, and then we use those parameters in test assertions. This is based on some work by John Reed, who has a site called Quality Coding. He's also got on GitHub, he's got a much more elegant example that I'm going to show you shortly. Now comes the code part. So it's all in Swift. He does it in Objective-C, and he's also got some work for doing UI alerts as well. So all this code is basically test code. There's no production code here at all. So Swizzling, we start at the lowest level. We do it in NSObject. The reason we do it there is that we can use this for any other object that we might want to swizzle methods for. So we write an extension to it called replace instance method, and it's passed two selectors. The first one's the original selector, and the second one's the one that we want to swap it with. And then we use this method called method exchange implementation. So basically what that does is change the implementation or the pointer to the function or method in the calling table. At the UIViewController level, this is where we swizzle the present method. So we change the present method with our own swizzle present method here. And in our swizzle present, all we do is capture the parameters that are passed to it, and we send out a notification. So anyone listening to that notification should be able to get access to the parameters that are passed to the presented view controller. The actual spy object itself, so we define a few internal parameters to capture the parameters that get passed on this notification. So when we initialize it, we listen for notifications, we do the swizzling. When we deinitialize, we swizzle back, so that returns it back to its original way, and then we stop listening for the notification. So when we receive a notification, we get this view controller was presented, gets called, and all we do is capture the parameters from the notification, and we're going to use these in our test assertions. So that's our swizzling spy, if you like. Now to the test setup here, there's a couple of things about this. Here we are testing the presenting view controller. So we create a local access to that called SUT, or system under test. We load it from the storyboard, and then we create our spy, which we're going to use in some of the tests later on. During teardown, we need to tickle the run loop here in order to clean up some memory. I'm not sure exactly why that is, but I think during the it may have to do with some strong references to the view controllers. But if you look at what happens while you deinitialize a view controller, if you put some print statements in there, you'll notice that they don't get called sometimes until after all the tests are run. But we would like everything cleaned up between tests, so that's why we pump the run loop here during the teardown. And then we set both the local parameters to nil, so that hopefully they get cleaned up between each test. One thing to note is that in order to get the presenting view controller from the storyboard, we have to give it an identifier in the storyboard. So you need to put that string in there, usually the same name as the class for the view controller itself. That's how we were able to get access to it. So earlier I said if we want to test, or some of the things to test, we need to test that there's something to initiate it. Here we're looking that we've got a button. Then we want to know that the Segue exists, and then that the Segue has an identifier. So in order to get the button test to pass, we've got to add the button to the storyboard, we've got to provide an outlet for it, and then we've got to connect them. To test that the Segue exists, we just look at the first of all the targets to the button. Now you might have more than one, but if you're only segueing from the button, then you should only have one, we would hope. In terms of testing the identifier for the view controller, for the Segue, I don't really care what it's called, all we want to know that it's got one. So the idea there is if someone changes the name later on, the test will still pass. And see how we can get access to the Segue from the button. Here's a couple of tests that you can use, but probably shouldn't use. The first one tests that it only responds to the one control event. All control events is a bit mask, so it could have multiple things in there. We've got another test there that tests that the button's only got one action, and the third test is that it's connected to a method called perform, which is the Segue method. Now, these are the sort of tests you can do, but probably shouldn't, because all you're doing is testing Apple's functionality, basically. So unless you've got a really good reason to, I wouldn't use these sort of tests. If you want to get access to the Segue from a table cell, then select a cell or grab a cell, and then we use key value coding to get the selection Segue template, which is a private property. So it's not available as a normal property, so in order to get access to it, we've had to use key value coding there. And again, we just test that the Segue identifier is not an empty string. For a gesture recognizer, it's a little bit more complicated. Again, we use the private properties to get access to the Segue using key value coding. The reason it's a bit more complicated is because you can have multiple targets on a gesture recognizer. So here we are actually testing the Segue itself. How we go about doing that is we've got two tests here. The first one is we want to test that the presented view controller is of the correct type, which is presented view controller. And the second test tests that we've got model object data, which is passed between the view controllers. In this case, it's just a string that we've passed to display on the presented view controller. So in order to do this, we create a window and set its root view controller to the system under test, which is the presenting view controller. And then we make sure that the window is made visible. This creates a view hierarchy. And then we can tap the button and then use our Swizzling spy to get access to the presented view controller. And then in the second test, we get access to the presented view controller and its model object. We don't test the UI on the presenting view controller. You should test its UI in its own test sets. So selecting a row, a table row, we've got to simulate tapping a row. Here we just select the row and then we call perform segue with identifier. It's not quite the same as tapping on a button, but I think that's the only way you can do it. And so again, we've got two tests for the presented view controller and the data model. With a gesture recognizer, the only way I could figure out to do that was to actually perform the segue itself. So that's about it. In summary, we've got a thing called a Swizzling spy, which is used to access our presented view controller. We can verify that the presented view controller is of the right type and that the data is passed between them. And we can access the segue using key value coding for things like a table row or a gesture recognizer. All we're really doing is testing that the segue exists and has an identifier, which is not an empty string. And all this is done on the test target, so there's no impact on the production code. Thanks very much, and I'd just like to, pay tribute to John Reed from Quality Coding. He answered a whole lot of questions from me and provided the inspiration for this. He's got on his GitHub, he has a much better example of how it all works, and he has one for an alert as well. And also Dominic Hauser, who wrote this book, Test-Driven iOS Development for Swift 4, where he started looking at this. That's where I got the inspiration from it, and an article by Joe Susnick. Cool, that's me done.